Hi everyone, my name is Deborah and today I'm going to be talking about the concept of zero knowledge proofs. Right. So this is a very crucial, critical concept, and I'm going to be demystifying um, and talking about it for the next few minutes. Right. So before I begin, I would like to talk about the drawback in the privacy of personal data. So when it comes to use as a user of an application, sharing your personal data with an organization. For instance, most companies would require valuable information about you on their application. Like, for instance, when you sign up on an application, you would ask some, valuable information about yourself that you'd have to impute on the application. So this information could be like a breach of privacy, and you mostly do not have like a choice but to share this information. So for instance, let me use the banks as an instance. So the banks when you create an account in the bank, you'll be asked to bring like a lot of valuable data to prove your ownership of accounts and all of that. And most of the time, the bank would keep your data private, but in a centralized manner. And the banks work have a centralized nature as opposed to the blockchain. And by centralized nature, I mean there's a central authority, which is the bank that is in charge of keeping all your private data. So while in blockchain you have Bitcoin, for instance. So the Bitcoin network is decentralized in nature, and basically that means that all your data and all the transactions you make, which comprises of your transaction history, is going to be made public on the blockchain, so everyone can see your transaction history as opposed to the bank. But yeah, the bank is centralized, while the Bitcoin network is actually decentralized. At the end of the day, you are not getting everything you want. Either you get either you're getting your data is actually kept private in the bank, and then with a central authority that's in the centralized nature, or your data is made public in Bitcoin with a decentralized nature. So at the end of the day, this brought about a problem and a drawback in privacy of people's personal data, and a good concern, and brought up a lot of concerns. So in the long run, something was kind of like put together, something was actually coined up, and that is what we refer to as zero knowledge proof. Okay, so I have like a Wikipedia link open here. So here I have the zero knowledge proof. So according to Wikipedia, zero knowledge proof is also known as zero knowledge protocol, and it's a method by which one party, the prover, can prove to another party, the verifier, that a given statement is true, while the prover avoids conveying any additional information apart from the fact that the statement is indeed true. So the essence of zero knowledge proofs is that it is trivial to prove that one possesses knowledge of certain information by simply revealing it. So the challenge is to prove such ownership without revealing the information itself or any additional information. So that's basically what it is, right? So back to my slide. Let me show you like an illustration of what zero knowledge proof is. So here you have Alice and you have Bob. Now Bob says no idea about solution, but Alice should know it. So now there's a problem here. This puzzle that Bob is trying to solve, and Bob does not know it, but Alice does. And Alice tells Bob that she knows the solution, and Bob asks Alice to prove it, right, without him seeing the solution. So now the challenge is done, and Alice gives back a response. So basically, how it works is Alice will have to be able to prove that she knows the solution to Bob without actually showing Bob the solution. Basically, that's what it is. So the whole back and forth several times would actually now prove that Alice actually has the solution to this puzzle, and then Bob would now be, convinced enough to believe what Alice is actually, saying. So with that, in before I move forward, I think I would want to also, talk about right. So basically, like I mentioned earlier, let's say you want to send money to somebody via a bank transfer or a check or debit card, whatever. Most of your transaction history, like I said earlier, is private, but it is centralized, meaning that all the data about your transaction is kept in the bank, which is also a problem, So a solution to this is something like Zcash. So before I talk about I think I would have, let me talk about the two types of, so basically you have like two types of the zero, not this should be KP, sorry about that. So it's, two types of the zero knowledge proof, so we have the interactive and we have the non-interactive. So right, so the interactive zero the zero knowledge proof is basically a situation where you have like a prover, and the prover in this case here is Alice. You have a prover that perform a series of actions to convince the verifier, which is Bob in this case, of a certain fact. So it's almost like an interrogation, right? So while non-interactive basically allows you to deliver proof that anyone can verify by themselves. And in another word, I can say that the non-interactive zero knowledge proof actually doesn't involve any interactive process. So basically how it works is the prover, which is this, the prover would basically create challenges and combine them together, and then the verifier could respond at a later stage. So basically, that's how it works. So this, looking at the arrow here, you see that the prover has like a function to make a proof, and then it sends a confidential info, and then it gets the proof, then sends the proof to the verifier, and the verifier will check the proof using this function that has already been defined, and then get the results. That's basically how it works. So if you from what I've said so far, you notice that in the zero knowledge proof, in zero knowledge proof concepts, you have a verifier and a prover, right? So the whole essence of this is the privacy of the web. And now we have an implementation of the zero knowledge proof, which is like a use case known as Zcash. So here I have opened Zcash here. So what are ZK snarks? So basically, Zcash would solve this whole problem, and it's going to prove the correctness of the transactions that go into the blockchain. So basically, it creates an encrypted, blockchain. It allows you build applications where users can retain ownership of their, their identities. That's basically what ZK. So basically, ZK Snacks is used by some cryptocurrencies to protect the privacy of their users, and so it uses the zero knowledge proof to hide the balance of transactions that are usually shown to the public, and basically that's what it does. So the full meaning of of snacks is succinct non-interactive argument of knowledge. So let's read here. You have here. So ZK hash is the first widespread application of ZK snarks, a novel form of zero-knowledge cryptography. So the strong privacy guarantee of Zcash is derived from the fact that shielded transactions in Zcash can be fully encrypted on the blockchain, yet still be verified as valid under the network's consensus rules by using ZK snark proofs. So the acronym ZK snark, like I said earlier, stands for Zero Knowledge Succinct Non-Interactive Argument of Knowledge, and it refers to a proof of construction where one can prove possession of a set of certain information, example, a secret key, without revealing that information and without, any interaction between the prover and verifier. So zero knowledge proofs allow one party, that is the prover, like I mentioned earlier, to prove to another, that is the verifier, that a statement is true without revealing any information beyond the validity of the statement itself. So for example, given the hash of a random number, the proof could convince the verifier that there indeed exists a number with this hash value without revealing what it is. So in a zero knowledge, proof of knowledge, the prover can convince the verifier not only that the number exists, but that they in fact know such a number again without revealing any information about the number. So the difference between the proof and argument is quite technical, and we don't get into it here. So substance zero knowledge proofs can be verified within a few milliseconds with a proof length of only a few hundred bytes, even for statements about programs that are very large. That's basically, so you can actually go through this and check it out. So you can check how ZK snaps are constructed in Zcash and how it works. You can also check how it works and all of that. You can also check how these snaps are applied to create a shielded transaction, and also the future applications of ZK snaps. So now there are several, use cases, like real life use cases of the zero knowledge proofs, right? They actually, so I said, like, in reality now we like basically reveal information about ourselves to like companies via the applications more than what we actually want to desire to reveal. Like, we actually don't have a choice, but we have to do that. So there's a way. I've mentioned that there's a way of providing companies with the data they need without actually revealing data itself. So basically, you're still going to be providing the companies with the data they need, but at the end of the day, you are not revealing the data to them. So there's still this privacy, like I mentioned earlier, of your, of your data, right? So right. So like for instance, proving that something is true without revealing the thing that you're actually proving. And I mentioned that it's such a technology exists, which is the ZK stacks, right? So Zcash. So right, how it works is that zero knowledge proof basically doesn't, sorry, a zero knowledge proof, yeah, the basic doesn't give you like 100% proof, but it gives you like, it minimizes the probability that someone is actually deceiving you and lying to you, you understand? So that's basically how it works. And right, so I've mentioned Zcash, and now I think can move forward and look at some of the real world applications of zero knowledge proofs. And here we have right. We have an overview of the zero knowledge proofs. And so basically what I forgot to mention is that the zero knowledge proof is actually a cryptographic method. Remember I said that it's basically creating an encrypted blockchain, right, that has your data. So your data is not going to be revealed to the organizations. They can't see your data, but there's a proof that the data is actually the data is actually valid and it belongs to you. So that is what zero knowledge proof actually does. So what I have here is zero knowledge proofs are cryptographic methods that allow someone, the verifier, to validate a claim done by a second party, the prover, without requiring the prover to reveal any underlying information about the claim. So basically that's it. So what the use cases now, we have data integrity, data privacy, and verifying computing are like key challenges and opportunities in a technology-driven environment, like I said earlier. So whenever we exchange data, we are exposed to the possibility of a data breach, which I mentioned earlier. So moreover, the data receiver has to ensure the integrity of the data that is being sent his or her way. So it's basically still, there's still a way to prove that this data is authentic and this data is actually valid, and without the receiver actually seeing this data. So at the end of the day, there's still data privacy that's been achieved. So yeah, so we have one of these cases is anonymous verifiable voting. So when it comes to distributed ledger technologies, establishing clear governance protocols has always been difficult. So to ensure appropriate on-chain governance structures, anonymous and verifying voting is crucial. So when it comes to voting, it's essential part when it comes to politics and democracy in the country and all of that. So it's possible for you to actually achieve anonymous voting with by implementing the zero knowledge protocols technology, right? So we also have for the private exchange and settlement of digital assets. So we said here that indeed transparency on the public blockchain was one of the factors that gave it trust. So it has major drawbacks. I mentioned earlier, like the blockchain is decentralized, right? So and all the data and transactions happen on the blockchain are public and everyone can see it, right? Right. So basically it's also publicly because the whole essence of the blockchain is for it to be publicly verified, and that is why it is public, you understand? So when it comes to privacy now, you can actually achieve private exchange assessment of digital assets by implementing the zero, knowledge proof or proof protocol. There's also privacy on public blockchains, like I mentioned earlier. So it's like the Zcash allows you to have like an encrypted blockchain, and right. So that's basically it. So the other use cases that you can actually check and do like a bit of research and see for yourself and all of that. So yeah, thank you for listening, and I hope you were able to learn a couple of things from this presentation. So just a quick recap. We talked about the zero knowledge proof. We mentioned basically like this illustration about how it works, where you have you have a prover, and then you have a verifier, right? And I mentioned the two zero knowledge proof types existing in interactive, where there's like back and forth interaction, more like an interrogation between the verifier and the prover, right? And then you also have the non-interactive zero knowledge proof as well, that like I mentioned earlier. So that's basically it. So at the end of the day, the whole essence of the zero knowledge proof is for it to like limit the issue of data breach that we currently have in our blockchain ecosystem. In fact, in our whole application system and all of that. So it's actually a very, very nice concept that should be implemented. And I hope you're able to learn a couple of things from this. So thank you for listening. Bye.